Hello learners and welcome back to VLSA Simplified. So in the last two videos, we explored the signal strengths and various net types like wire, wired R and tri-rect. Those were all about how signals connects across modules. Now it's time to shift the gears and talk about the other half of Verilog data types. The ones used inside code blocks like always and initial. These are called variables in Verilog. And in this video, we will walk through some of the most important ones like registers, integers, time, and real. We will see how each one works and where to use them. And let's get started and let's see what you will learn in this video. So in this video, we are diving into a new set of data types, that is variables in Verilog. These are the ones you will most probably use inside always and initial blocks for storing temporary values, counters, timing, and even math. We will look at four key types. Reg, the essential for modeling sequential logic. Integers, handy for loops, indices, and test bench values. Time, used for storing simulation timestamps. And real data time, which is used for floating point numbers for simulation only logic. We will go through each one with the syntax and small examples, and in the next video we will simulate them in ModelSim so you can clearly see how they behave. Alright, this is VLSA Simplified. Let's get started and let's simplify.
Feel me like a Hellcat.
Reg. So reg is probably the most widely used variable type in Verilog. Even though the name says reg, it doesn't mean always maps to a hardware register. Think of it like a storage element used inside a procedure block like always or initial. You cannot assign a value directly to a wire inside a always block. That's where reg comes in. It lets you store and update values dynamically as your simulation progresses. In the example here, we are initializing two reg. One is A and B in an initial block. On simulation, A will get a value 0 and B will get 1. And reg is synthesizable if you use it in a proper always block that infers a flip-flop or latches. So, whenever you need a variable that holds a value across a simulation cycle, you will most likely use a reg. Next is integer. So integer is one of those Verilog type that make writing test benches and temporary logic super easy. So it declares a 32-bit signed variable and it's mainly used for things like loop counters, display values, or temporary results in simulation. So in the example, we are using I to iterate from 0 to 3 in a for loop and print each value. This is very common when you are writing test benches or checking output during simulation. But here's something important. Integer is not synthesizable. It's only meant for simulation purposes. So you don't use it in a RTL design that will go to a hardware. If you need a similar functionality in synthesizable RTL, use reg 31 down to 0, a vector instead. Time. Time is a special purpose Verilog data type that's designed to hold the current simulation time. It's very helpful when you are trying to measure a delays, logic execution timings, or just to print when the event happens. By default, time is a 64-bit unsigned variable, which means it can handle very long simulation durations without overflow. So in the example, we are using a $time to capture the current time at two different points, and start and finish, and then display the difference. So like integer, time is also not synthesizable. It is only available in simulation environments and especially in test benches or debug code. If you want to track performance or figure out how long something took in simulation, the time is your best friend. Coming to real is used when you want to deal with the decimal values like something 3.14 or 0.001. So it's a double precision floating point type. And just like integer and time, it's intended for simulation purpose only. You will often find real in test benches, verification code, or mixed signal modeling, where you need accurate mathematical calculation that go beyond zeros and ones. So in the example, we assign 3.14 to a real variable and print it using percentage %0.2f. So this percentage %0.2f, it limits the output to 2 decimal places. It's important to remember that this is not synthesizable. No FPGA or ASIC tools will let you implement a real based logic in the actual hardware. But for simulating analog behavior or double precision calculations during the testing, real can be very handy. Alright learners, we have just wrapped up the theory part of Verilog variables. You now understood what each variable type does from reg to integer and time and real, and where these variable types fit in simulation or in hardware. In the next video, we will bring this all to a life inside a model sim. So we will simulate the same examples we just discussed and watch how each variable behaves step by step. So don't miss it. And if you haven't already, hit the subscribe button so you will be notified when it drops. See you in the next video. Bye.